All right, so day 8, this is talking about factoring polynomials completely. So usually this is probably going to be it's going to be bigger than a trinomial. Sometimes it might be a trinomial. Really fine. So this is just like how to factor them out completely. So we have x squared plus y plus x plus xy. So first thing I'm going to do is going to group them with all of my terms with x's together, and then my ones with y's. So I'm going to have two sets of terms grouped together, and I'll show you why in a second. I know this one right here has an x in it, but since it has a y, I'm going to leave it separate right now, and I'm going to factor or group it with the y. So I'm going to rewrite this as x squared plus x plus xy plus y. So let's see, can I factor anything out of the purple, the x squareds? Looks like I could factor out an x, and I would get x plus 1, and then plus, what can I factor out from the other one? Would be a y, so then that would be parentheses x plus 1. Oh, weird. These two match up, so that's planned. You want that to happen. Whenever you factor, you want to have the two things in the parentheses the same. So now this would be equivalent to x plus y, so I just took the things from the outside, times your purple underline there, x plus 1, what's in both sets of parentheses. And then that should be your answer. Let's double check it by distributing. X times x is x squared. X times 1 is plus x. And then y times x is xy. And then y times 1 is y. And if you look, all of those are up there. They are in a different order, but it doesn't matter because we're adding. And this does work. So this is going to be your answer of how to factor those. Okay, so going to the next problems, we have 3x cubed plus 6x squared minus 18x. So do you see anything right off the bat that we can factor out? I see that we can factor out the 3x from every term. So that would be 3x. So 3x cubed divided by 3x would give me, what would that be, x squared? 6x squared divided by 3x would be 2x, and then 18x divided by 3x would give me negative 6. So now that I have 3x factored out, let's see, we have a pretty easy looking trinomial in here that looks like we can factor out. So let's go ahead and factor. So now let's think about, we have our b is 2 and our c is negative 6. So that tells me we need a positive and a negative, and since our b is positive, our bigger number will be positive. So let's think of two numbers that when you add together you get 2, and it's going to be a positive and a negative, and when you multiply you get negative 6. What would that be? Oh, looky here, this problem is not factorable. I've thought about it and I've looked around, and you cannot actually factor. So, trick question, I didn't even know it until I started doing this problem. Your answer will be 3x parentheses x squared plus 2x minus 6. And that is as far as you can factor. You cannot go any farther. So that will be your answer. Let's talk about this next one, letter E. Looks like I can factor out an m from all of the terms. So I have m parentheses m, so m cubed divided by m would be m squared minus 2m minus 8. Let's see if this one's factorable. I hope it is. So we know we need a positive and a negative because our answer, our c is negative, or we'll just write that down. B is negative 2, c is negative 8. And since our b is negative, we know our bigger number needs to be negative. So two numbers that add together to be -2 and multiply to be -8 would be, what would that be? Looks like -4 and 2. -4 and 2. Perfect, this one works. So we would have m parentheses m plus 2, and then parentheses again m minus 4. And that would be factored out as far as you can, so that will be your answer. If you want to double check, you could distribute everything and check it, and you should get the original problem. All right, so now we have equations. So no big thing. And this first one, letter F, we need to get everything on one side and a 0 on the other, so that means I need to subtract 10x from both sides. So that would give me 2x cubed plus 8x squared minus 10x equals 0. All right, not too bad. Now what can I factor out, make it easy as possible before we start factoring? So it looks like we could do 2x out of everything, and you would get x squared plus 4x minus 5 equals 0. Now let's see if I can factor. So if I have, this is my b and this is my c. So my b is 4, my c is -5. So that means I need a positive and a negative. And my bigger number needs to be positive because my b is positive. That would be, so plus 4 times -5. That would be what? Positive 5 times -1. Right? So 5 and -1 would be positive 4, and 5 times -1 would be -5. So yep, it would be 2x parentheses x plus 5 parentheses x minus 1 equals 0. And since we're solving, I believe in the book they want you to go ahead and solve, so it wants you to find the roots. I would have 3 of them for this one. You would have 2x equals 0, x plus 5 equals 0, and x minus 1 equals 0. And this would just be x equals 0. This would be x equals -5, and this would be x equals 1. So those 3 would be your answers. All right, last problem. Hopefully if I have enough space. So I don't have to move anything over because we already have 0 on one side. So let's go ahead and just factor out what we can. It looks like we can just factor out a w. So that would be w squared minus 8w plus 16 equals 0. Now we have our b is -8 and c is 16. And so that means we need 2 negatives. So what adds together to be -8 and multiplies to be positive 16 before -4 and -4, right? So we would have w parentheses w minus 4, w minus 4 equals 0. So there's that. I'm going to erase this. So there's that in factored form, and I believe they want you to go ahead and find the roots since it is equal to 0. So the first one would be this w equals 0. That's easy. We don't have to do any work. W minus 4 equals 0, and then we have another one, w minus 4 equals 0. So we have w equals 0, w equals 4, and then w equals 4 again. You don't have to write it twice. So these two would be your roots.